Hello, and once again welcome back to my channel and to the series ConQuiz. Today is ConQuiz 5. In ConQuiz 4, the last session, we have started Chemical Kinetics, concept booster on Chemical Kinetics. Right? In that session, we have discussed a quick review through question and answers like true and false. But today, we will be observing in a slightly different way. And that is part 2, Chemical Kinetics, understanding through equations, right? Of course, as I have already mentioned a number of times, that this aim of this series includes supporting my friends, younger friends, for preparing different exams, BSc Chemistry Honors, IIT-JAM, NET, GATE, SET, etc. But today we'll follow a little bit different strategy. Before going for questions and answers, we'll have a quick review of some of the important equations that we follow in chemical kinetics, and then that would be applied for different problems. Okay. So let us start with a simple reaction A to product. So what do we mean by rate of this reaction? So it can be either you can say minus ddt of A, rate of consumption of A. So minus sign is there because dA dt itself is negative, so rate has to be a positive quantity, or dP dt, rate of formation of product. For a little bit more complicated reaction like A plus 2B, 3C plus D, so the stoichiometric coefficients are 2 and 3 for B and C. In that case, we can think of different rates, rate of consumption of A or B, and rate of formation of C or D. So these rates, individual rates, are different, but how they are related and how they relate to the overall reaction. So this is the question. RA is half RB, is 1/3 RC, and half. You look carefully that half is there for RB because 2B is there in stoichiometry. Similarly, 1/3 RC is there because 3 is there with C in the stoichiometry. So in other words, ddt of D is 1/3 ddt of C equal to minus ddt of A because A is reactant and B is also reactant, so minus half ddt of. So this is the relation. Now we measure experimentally concentration of reactant or product at different times, so A and T. So of course, to match with our experimental results, we need the mathematical quantities that we can get only after integrating the differential rate law, the last one. So let us now discuss the rate law. But remember that the rate of a reaction depends on, number one, the nature of the reaction, of course, temperature, and another quantity which we call order, and all these are expressed in the rate law. We call it differential rate law of order n, and we express like this. So R is k a to the power n. So n is some measurable quantity, experimental quantity. Okay. Now we have to integrate. So for simplicity, let us start with n equal to 0. So R is k a to the power 0. So if we just integrate both sides, dA is minus k dt, put the limit initial a0 to a and time t equal to 0 to t, then you get the equation at equal to a0 minus a. Right. Now one more important concept, t half. So t half is the time taken for the reaction for AT to reach half of the initial concentration, that is a0 by 2. So AT becomes a0 by 2, and if we equate now the t is t half, then so you can easily solve for t half to be a0 by 2. So that is for 0th order reaction, t half is given by a0 by 2. And one more important thing from the same equation we can derive here, that whether, if you ask a question whether the reaction would go for completion or not. Now what does it mean, completion? That means there would be no reactant left. That means AT would be 0. Okay. So if you put it AT equal to 0, and that would give you A0 minus KT comp, the time for completion. So that would simply give you T comp is A0 by K. So look it carefully that T comp is A0 by K and T half is A0 by 2. Okay. Now for another example, the first order reaction. A to P, the same approach, but integration would be slightly different. So it would give you dA by A is minus KT. Okay. Now if we put the limit A0 to A and 0 to T, then you will get an equation like log A by A0 is minus KT, or A equal to A0 e to the power minus KT. So K is a constant for that reaction, A0 is also constant for that reaction. So you see that A at different time, it exponentially decays with T. Of course, the rate of decrease would depend on the numerical value of K. So if we just have a plot, it looks like A by A0, this ratio, it is an exponential decay, but the decay constant, you can say if K is small, then it slowly decays, but if K is bigger, then it decays faster. Okay. That is quite obvious from the equation and from the graph as well. Now, next example, second order. So this time is A to the power 2, and if you integrate again, then you can check it. You will get at the first attempt, you will get 1 by A is equal to 1 by A0 plus KT. But if you are interested to get simply A at different time, then a little bit of manipulation would give you this equation. T is in the denominator, so as time increases, the denominator increases. That means the overall right hand side would decrease, but that would not be an exponential decay like the first order. Okay, that you have to keep it in mind. And then just a quick review that A to P kind of reaction for first order reaction, the equation, indicated equation is like this, and half life is ln P by K. For second order reaction that I have already deduced, again you will get these equations, either first one or the second one, and P half is 1 by here AC. You notice carefully that in the first order T half there is no A0, but in the second order T half A0 is there. Now in general, you are interested in general nth order, then what would be the expression of integrated rate law or the T half? So the answer T half is given here, but let us look at it more carefully. So nth order reaction, so it is A to the power n. Now separation of variables followed by integrations gives you this equation. You just please do it on your own copy later on, and then after integrating and putting the limit, you get this equation, and a little bit of manipulation, that multiplication both sides by 1 minus n, A0 to the power n minus 1 gives you, for convenience, you are doing this manipulation, that A by A0 whole to the power 1 minus n is 1 plus this quantity. Okay. Of course, you remember in mind that 1 minus n, so if n is 1, then it is undefined quantity to the left hand side. So the whole equation is not valid for n equal to 1, otherwise it is valid. Okay. Now you are interested in half life, so we just put A at this equation, A to be A0 by 2 and T is T half. Then it would give you the equation that I have presented in the last slide. T half looks like this. It depends on the order of the reaction, it depends on A0, it depends on K. Okay. So A0 is there, only first order A0 is not there, and so this equation is not valid for first order, so there is no problem. Okay. Now let us start with a concept booster, really a concept booster problem. The question looks like, for the rate law R equal to K e to the power n, that means a general nth order reaction. For what values of n does the reaction go to completion in a finite time? Okay. So completion, we know the meaning, that the time taken for the reaction for which the reactant concentration A or AT becomes 0. Right. Now the answer is that for n greater than equal to 1, any value of n greater than equal to 1, the completion time would be infinite. That means the reactions practically will not go for completion. But for n less than 1, you will get a T completion finite time. So we'll analyze this, how these answers are coming. Okay. As I promised you that we'll discuss today a few review equations and concepts. So case 1, n equals to 1. So it's rather simple because we can use the rate integrated rate law, a equal to a0 e to the minus kt. So when a becomes 0, this equation itself suggests you that only at t equal to infinity, so e to the minus infinity gives you 0, so a would be 0, right? So it takes infinite time for completion, but that is for n equal to 1. So what are the other possibilities? Case 2, let us say that n is less than, okay. So again we start with the general equation that we presented in the earlier slide, that this is the integrated rate law for nth order reaction. Now for a to be 0 in the left hand side, 0 to the power 1 minus n, remember that n is less than 1, so 0 to the power some positive quantity, and that is 0. So the left hand side is 0, and that gives you the right hand side to be equal to 0. So this equation becomes 0, and from here we can find the T com would be, from this equation it would be a 0 to the power 1 minus n by k into 1. But here you judge it carefully that it's a positive finite quantity since n is less than 1. A 0 to the power 1 minus n, and n is less than 1. Okay. So n less than 1, it's okay, fine. Now n greater than 1. So again we start from the same equation, starting equation, a by a 0 to the power 1 minus n, and here it's a trick that for n greater than 1, so 1 minus n would be negative quantity. Now for a to be 0, so 0 to the power some negative quantity, that means 1 by 0 to the power some negative positive quantity, that means 1 by 0. So finally the left hand side becomes 1 by 0 kind of thing, and that is infinite or undefined, right? So the left hand side itself is infinity for a to be 0 and n greater than 1. So naturally the right hand side is also infinity, and that is possible if only T comp is infinity. So what we see finally, the answer is that for n greater than or equal to 1, it takes infinite time, and for n less than 1, it completes in a finite time. Okay. Now we'll be using those concepts and equations that we have discussed so far for a particular type of problem, that is identifying or justifying the order of the reaction, either 0, 1, 2, or we are restricted to only this 4 values 0, 1, 2. So I'll be giving some conditions, and you have to verify or justify or find out that which order the reaction belongs to. The first one, P half into A0 is constant. So this is n equal to 2, and you can verify because T half is 1 by k A0. So T half into A0 is 1 by k, that's a constant. So the answer is n equal to 2. Got it? So this is how we can follow the next problems, a series of problems. Mostly actually will be verifying, knowing the answer, that supposing that you are giving a trial and error basis, so you can finally justify the answer. You are not really finding it out from a very general equation, that you keep it in mind. So the next question, slope of log T half versus log A0 is minus 2. So this time of course we can start with a very general expression T half that we have already given. So you take the log both sides. So you can ignore the first part except the A0 part, because we are interested in the right hand side, only the A0 term. So log of something, you don't bother about that something, minus, because this A0 to the power n minus 1 is the denominator. So minus is coming, n minus 1, this n minus 1 power of A0 comes here before log A. So log T half and log A0 gives you a straight line with a slope of minus n minus 1, and that is minus 2 given. So simply n equal to 2. So it's verified that the order for this question is 3. Got it? Please try it on your own, if not that. Next question, T half is temperature dependent. Okay, for which order? Actually, T half is temperature dependent irrespective of order. So the answer is n is all 0, 1. The next question, rate is independent of initial constant. So rate is k a to the power n. Now if r needs to be a independent, that means a to the power n must be 1, just 1. So n must be 3. So numerically r equal to k constant. Okay. The next question is in the same slide because it's actually parallel to the first one. Rate versus time plot runs parallel to time axis. That means actually it's saying that rate is constant, and that we have seen that rate is constant for n equal to 0. So the answer is n. So the next question, time of completion is twice half life. So actually we have already discussed this partly. The answer is order n equals to 0, and at is a0 minus kt. So as we have already seen that t half is a0 by 2k, but t completion is a0 by k, right? So if you start with t comp a0 by k, you divide and multiply by 2. So it is 2. This is not minus actually. So 2 a0 by 2k, but a0 by 2k is t half. So actually it is 2 t half. So t comp is twice that of t half for n equals to 0. Okay. Unit of rate constant is mole to the power minus 2 meter square second. So start from a very general expression. Rate is k to the power n. Now rate is m is inverse, and right hand side k m to the power n. So k is finally m to the power 1 minus n second. Okay. Now in the question it is mole square liter inverse. So let us see what it is actually. Mole to the power minus 2 liter square is actually molarity to the power minus 2. So what it is given in the question is that molarity to the power minus 2 second inverse, which is given, and it is equal to m to the power 1 minus n s to the power minus 1 for nth order reaction. So the job is to find the value of n. So obviously from this equation, this power of m is minus 2, and here it is 1 minus n. So minus 2 is 1 minus n. So n is, so the answer is n equals to. Got it? Well, the next question, product concentration versus time plot is a straight line passing through the origin. So again we can start. Okay, the answer is 0, but let us justify that A to P, this kind of reaction. Now rate we are expressing in terms of the product. So dp dt, no minus sign is there, equal to k a to the 0. So integrate dp equal to k dt, p0 to p limit, and time 0 to t. So we get pt equal to p0 plus kt. Of course it's an equation of straight line, but with an intercept p0. But if we assume that there was no product concentration to start with, p0 equal to 0, then of course it does match with the question that it's a straight line passing through the origin. Okay. Next question, log t half versus log a0 has a 0 slope. Again the answer is 1, and we will verify that. So t half is ln 2 by k, and of course t half is not a function of a0, it doesn't depend on a0, right? So if you plot log t half against log a0, it would be a parallel line to the x-axis, that a0 axis, log a0 axis, and parallel to this axis, that means having 0 slope. So the answer is very clearly order n to 1. Next question, 1 by a square versus time plot is linear with a positive slope and intercept. The answer is 3, and we will verify that. Well, a to p, now rate expression involves a to the power 3 order 3. So if you separation of variable and then you integrate, dA by aq is minus k dt, and put the limit a0 to a, 0 to t, you will get equation like this. and clearly it shows that it's a straight line of slope 2k and intercept 1 by a0 square. Both are positive quantity here. So I think I've got it. The next question. Log A versus time plot gives a negative slope this time and positive. Okay. So this time the answer is order 1. Verify. So start from the equation ln A by A0 is minus kt. So ln A is ln A0 minus kt. Okay. So slope is minus k. K is a positive quantity always. And intercept is ln A0 which is a positive quantity. So as per the demand of the question, the order is n. Rate versus reactant concentration. Next question is linear. Rate versus reactant concentration and passes to the order. So again the order is 1 and let us verify that R is k a to the power n general and n is 1 here. So we demand that it gives y equal to mx kind of curve. Here you are directly plotting R versus a, y equal to mx. So that means a to the power 1. That would only give you y equal to mx type of curve. So the order is simply 1. Okay. It's simple but a little bit tricky. The inverse of half lifetime of the reaction is proportional to the rate constant of that. So this kind inverse of half. So answer is 1, but let us see. T half is ln 2 by k that we know for first order reaction. Then inverse. So ln k by ln 2 is 1 by 2. So naturally, if you plot 1 by t half, or if you see that 1 by t half is proportional to the rate constant. Okay. Well, unit question. Rate constant has an unit of meter second inverse, meter. Molarity second inverse. It's the zeroth order reaction. A to the power n. Now rate is m s to the power minus 1, and the right hand side k a to the power n. Well, and a to the power n must be unitless because the question demands the rate constant is m s inverse. So a to the power n must be unitless. That means 1, and that is possible if n equal to. So the answer is n equal to. Well, next question. When initial concentration is double, half-life period becomes 1/4. So what is the order of the reaction? The answer is 3, and we will verify why it is 3. So again we can start with the general expression of T half for nth order relation, and if you ignore the rest of the terms, you are just focused on A0 as per the demand of the question, that we see then T half is proportional to the term A0 to the power 1 minus n. Remember that here A0 to the power n minus 1 is in the denominator. So let us call that T2 and T1 are the half lives of two reactions 2 and 1. So T2 by T1 is A0 is A2 for second reaction and A0 is A1 for the first reaction. So it gives you A2 by A1 to the power 1 minus n. Now the data given that T2 by T1 is 1 by 4 and A2 by A1 is 2, because A2 is double that of A1. So 1 by 4 is 2 to the power 1 minus n. That means 2 to the power minus 2, 1 by 4 is 2 to the power minus 2 is 2 to the power 1 minus n. So if we just equate the power of both sides, you will get minus 2 is 1 minus n, and that would finally give you n equals to 3. Okay. And the last question, square root of rate versus concentration gives a straight line with slope equals to 4. What are the order and rate constant? The answer is order is 2 and rate constant is 16 unit. How? So R is k a to the power n. So if you take the square root of both sides, so root over R is root over k a to the power n by 2, and according to the question it is given as 4a, because it's a plot of root R versus a and only slope is 4, so 4a. So that means if we equate that root k would be 4 and a to the power n by 2 is a. So let us equate one by one. So a to the power n by 2 is a, that means n by 2 is 1. So n is 2. And root k is 4. So k is 16, right? So these are the set of questions for exercise that we are assuming that we have to remember some of the equations, basic equations, and if you keep on practicing, actually you don't need to remember it, will come automatically. And we have today demonstrated that how the equations can be applied for solving this kind of questions, and these are the very frequently occurring questions in different types of things. Okay, so hopefully you have liked this session. Thanks for watching. Our next video would be coming soon, session 6, and that would be on chemical kinetics part 3, and that time it would be understanding chemical kinetics through diagrams and graphs. And so please keep on watching, to subscribe, encourage your friends to subscribe, to watch, and to suggest me whatever you want to develop it further. Thank you very much. Thank you once.